So my session today is all about Citrix HTML5 redirection. And before I get started, I need to make sure that I give a big shout out to GO-EUC because they have been helping me out very much. Basically, they made the research possible. And I'm not sure if everyone already attended Ryan's session earlier today. But a quick run through to GO-EUC is that GO-EUC has this awesome mission to facilitate individuals with research capabilities to explore new technologies. So short history lesson on GO-EUC itself. They started in September 2018, very recently transformed to a non-profit foundation. Which allows them to be fully independent and unbiased. But their main goal is that they are for and by the community, which I'm the living proof of, to be honest. And this is all possible thanks to the sponsors. So another shout out to LoadGen and ICT partners. The cool thing about GO-EUC is that they not only offer you a testing platform where you can, as they say, explore new technologies, but they also have a fully automated test run, which not only focuses on the workflows that you want to run, but also on setting up the entire environment with the launchers, making sure the infrastructure is all booted up and has a clean bill of health, so to speak. And they also ensure that they capture all the data, test data, performance data that you need for your research. And if we're looking at the data sources, you'll quickly notice that they use a lot of different data sources to gather as much data on the test run as is possible, basically. So they're using LoadGen with the launchers for the application data, Perfmon for the VM data, ESXtop, and even remote display analyzer to make sure that they also have details on the protocols that are being used. And the other cool thing, that, or at least, well, it's less cool for me because I still owe them a blog post, but every research that they run results in a nice blog post with all the test results, any conclusions that they can draw from the results, and even some recommendations in some of the cases. And I'm pretty sure most of you have already checked out the blog and found it to be very resourceful and very useful to make sure that we enable a great user experience. Back to my topic, HTML5 redirection. So one of the reasons why I wanted to do some research on HTML5 redirection is, I've been in the industry for quite some years now. I'm not going to state exactly how many years, but I still remember using Flash redirection to offload some of the video encoding to the endpoint and make sure that I can have a smooth user experience within the VDAs. But what I most remember about Flash redirection is that it wasn't very easy and very stable to set up because it took a lot of different components, both on the endpoint and in the VDA to even work together, and you had to keep full control of all the versions that were running on the different systems. Back in 2017, Adobe already announced the end of life for Flash, which basically means that by the end of 2020, Adobe will stop updating and distributing the Flash player. And this also results in Citrix responding to that by saying that they will maintain and support HDX Flash redirection until the end of 2020, but they strongly recommend you to switch to HTML5 video redirection wherever possible. So that triggered me to do more research on HTML5 redirection. So the components of HTML5 redirections are a JavaScript, which basically is the hook that intercepts any video commands on the website. And it's the other core components are the WebSocket service, which runs on the endpoint and basically renders the video encoding, and the WebSocket agent that runs within the VDA. Both services or executables are installed with the Citrix receiver for Windows, or the Workspace app that it's now called, and the VDA installation. So there's no additional installation required for those parts. And they both use the WebSocket SSL certificates, which are also installed automatically. The main component in this whole scenario is the JavaScript, because basically that makes this solution only available for controlled websites. Because you actually need to have that JavaScript available on your website, web server, and include the script in your web page source code. And the other kind of limitation is that it only allows redirection for progressive downloads in MP4 format. So the bad news basically is that with the limitation of the MPV format, they basically rule out any usage of websites like YouTube. Because they use an adaptive bitrate technology. So unfortunately, this already limits our use case, as Citrix also recommends it to be used for controlled web pages, as they said, basically to stream training videos through your intranet sites. HTML5 is configured through a couple of policies, which are pretty straightforward. And in case you want to know a bit more, do a more deep dive on the policy settings and the effects they have, Citrix offers a nice decision tree to support you with any decisions and policy settings. Because basically there are two main considerations when you are configuring the policies. The first one is that you need to consider where you want to fetch the video content. The second one is where you want to render the video content. So you have, for both questions, you have two options. So looking at the first combination, it will be server fetched, server rendered, which means that the VDA will fetch the video content from the web server and also renders and encodes the video within the VDA resources. The second one is server fetched, client rendered, which basically means that the server will still fetch the video content, but pushes it through the virtual channels to the client to have it encoded, rendered over there, and streamed back through the virtual channel to the HDX session. And the last one is client fetched, client renders, because the policies also allow you to basically have the endpoint, the client, directly fetch the content from the web server in case they have a direct connection to the web server. So they can render it on the endpoint and then use the virtual channels to push it back and show it in your HDX session. During our test, we mainly focused on server fetch client render, but that's mainly because our endpoint did not have a direct access to the web server. So what did our test case look like? So on what kind of hardware did we run? As I said, GO-EUC was kind enough to lend me some test time in their GO-EUC lab. And we basically set up a scenario where we use the Citrix Cloud control plane for all the infrastructure components, used the GO-EUC lab for the load gen launchers, and a GO-EUC player, which is a containerized web video streaming service that Ryan built and looks awesome. And the other component was we wanted to make sure that we could also use a GPU during our tests. So we decided to use a Windows 10 system, one of the NV6 series within Azure. And with all the VPN connections connected, everything would run very smoothly. So what EUC does is that it uses these load-gen launchers to launch the different Citrix sessions and then run the workflow, the test within that session, collect all the data, bring down the session, and then spin up another one through these launchers. What we quickly discovered during our first test run is that our load-gen launchers were not able to offload the video rendering. So our client redirection did not work properly. And as we had very limited time to make the test runs successful, we decided to basically switch to a physical endpoint. And in our case, that was the UD3 IGEL thin client. So in this, in our runs, we had the UD3 client connect to the Windows 10 machine through the Citrix infrastructure and have a Chrome browser within Windows 10 to connect to the video player. And we used 3 different test scenarios, so to speak. As I mentioned, we're using the NV6 series, so we had the GPU available. So in the first scenario, we used the GPU to basically render the video within the VDA. And we're not using any HTML redirection. So this allows us to basically have one of the baselines for GPU-enabled video rendering. The second scenario, we disabled the GPU so that it would only rely on the CPU for any video rendering. Because in this scenario, we also decided to disable the HTML redirection. So we had a nice baseline of only CPU rendered videos. And the last scenario, once again, the GPU was disabled in the VDA. But we enabled HTML redirection, which allows us to render the video on the IGEL thin client and then use the virtual channels to stream it to the VDA and present it to the end user. So let's talk user experience. As I said, we only had, because we couldn't rely on the launchers, we had to manually start our test runs from using the thin client from IGEL in the VDAs. This meant that we only had, we had to decide to only use a limited run of 10 test runs per scenario. The good news was that we could watch while these runs were being tested. And then we quickly discovered, as we kept an eye out on the test runs, that we did encounter some bad runs with the HTML5 redirection scenarios. Of course, being trying to be a good researcher, I decided to not have those bad runs pollute my test data, so I cut them out. But that basically leaves me with a very limited test result set, because now I only have 5 good runs left to compare them with the other 10 to 9 runs that were good for the other scenarios. But still, I wanted to present the data that we had using those good runs. So if we focus on the VDA CPU utilization as a whole for the VDAs, you'll notice that there is only a slight difference between the scenario where we enabled HTML redirection in blue and the scenario where we disabled HTML redirection, which is the orange one, which only had 9% more CPU utilization. And of course, as expected, if you throw in a GPU, the CPU will be very thankful and relaxed, leans back and lets the GPU handle all the encoding. So those were the expected results. To zoom in a bit more on the CPU utilization, I also focused on the CPU that was used for video encoding specifically. And what you'll notice is then the HTML5 redirection definitely makes a difference because it does offload the CPU in your VDA. Because now the endpoint is also kicking in and helping with video encoding. So you'll notice that there's a 50% difference between having HTML5 redirected in blue and having it disabled in the orange case. And once again, having that GPU there definitely keeps your CPU in a happy state. The other thing that I was very curious about with, especially in our scenario where we had server fetched client rendering HTML redirection, was whether or not the bandwidth consumption would be very high due to the fact that it had to communicate through the virtual channels all the video data. And what you see is that at the first run, the first couple of seconds in our tests, you'll notice that there's a huge spike when we had redirection enabled in the bandwidth consumption. And then it basically lowers to almost a similar bandwidth consumption as the scenario where we disabled redirection. So looking at the percentage perspective, basically the bandwidth consumption is almost similar whether or not you're using HTML5 redirection or not in this case. But of course, this wouldn't be a very good research if we also didn't discover some surprises, so to say. So one of the things that we discovered, and I do hope that audio is working as well for the next video, is that we saw an offset in the overlay. And basically what I mean, please let me know if you can hear the audio or not.
Yeah, you could hear the audio, Esther.
Oh, perfect. So what you see here is that the overlay basically is offset. And what we notice is with a slight movement of the mouse, it would snap back and cover the original video frame. But to me, and I'm pretty sure that you'll agree with me, that doesn't really give you a lot of faith in a good user experience. And then there was this other phenomenon that we discovered. I already read through some of the troubleshooting tips from Citrix that they basically suggested that in some cases the JavaScript could fail to load. And I have to admit that those bad runs that I had to cut out of the research results basically showed us that, well, in 4 to 5 out of 10 runs, the JavaScript didn't fully load. So, and to our surprise, what you'll notice is that with every run, it basically does a refresh. And to our surprise, we figured that this meant that HTML5 redirection was not happening at all. But if you listen very closely, you'll notice that there's still. And if we zoom in on the RDA to look at the frame
Esther, we got a couple of things here. Number one, we're out of time, and number two, yes, we couldn't hear you.
Okay, I'm sorry.
Because the system audio is so loud.
I'm sorry about that.
That's all right.
Okay, so I will just round up within the 1 minute that I hope you will give me. So my conclusion basically is that HTML5 redirection is not performing very well, or at least not performing stable. But due to the limited test results that I had, I promise you that I will do some additional research because there are alternatives, as the browser content redirection from Citrix itself still needs to be tested by me. And I also want to check out the solution from VMware. So thanks for letting me throw that in, Gabe, and
Hey,
I will give it back to you.
I didn't even know you were going to say the company I work for at the end of this. So
No,
yeah.
I know, but that's the nice surprise, right?